Alright, so question 11 asks to find some vector space which is not a true vector space, being that not all the axioms hold true. And these 10 axioms are u plus v equals v plus u. U plus v is within the set of v, so basically the vector space is closed under addition. U plus v plus w equals u plus v plus w. U plus 0 equals u, so there's some zero vector that you can add to any vector within the vector space, and it will give you back the vector that you added. U plus negative u equals 0, so there's some for any given vector within the vector space that there is some other vector also within the vector space that you can add to it to get the zero vector. Cu is within the set V, so that means the vector space is closed under multiplication. Cu plus u plus v equals Cu plus Cv. C plus d times u equals Cu plus du. C times du equals Cd times u. And 1 times u equals u. So that's basically saying that there's some identity vector you can multiply any vector by to get the exact same vector back. Alright, so to satisfy all but one of these conditions, I chose the vector space of all even numbers, including 0 and negative even numbers, and to find addition in the standard way, so 2 plus 2 equals 4, and multiplication, once again in the standard way, 2 times 2 equals 4. So for the first axiom, as you can see, addition is obviously commutative. 6 plus 4 equals 4 plus 6. And the vector space is also closed under addition, since any even number plus another even number will always be even. Addition is also associative. As you can clearly see, 6 plus 4 plus 2 equals 6 plus 4 plus 2. And the zero vector in this particular vector space would be 0. And 0 plus any even number just gives you back the even number itself. And similarly, for any given even number, there's also a negative even number that, when added to it, will give you the zero vector. For example, take 4, whose plus, when you add negative 4 to that vector, will give you 0. The one axiom that's not satisfied is axiom number 6, where the vector space is closed under multiplication. So in this case, you can clearly see that is not the case. For example, take 1.5 multiplied by 2 will get you 3, and 3 is not an even number. So axiom 6 is not satisfied. Axiom 7 is satisfied since multiplication is distributive. In this case, 3 times 6 plus 4 equals 3 times 6 plus 3 times 4, which equals 30. Number 8 is a combination of the distributive rule for multiplication and the associative rule for addition. So, and both previous conditions are satisfied. For example, 3 plus 5 times 2 equals 3 times 2 plus 5 times 2. And axiom number 9 is the associative rule for multiplication, and obviously that rule, the rule holds true for multiplication, so 3 times 5 times 2 equals 3 times 5 times 2. And finally, number 10, the identity vector in this vector space is 1, with any even number multiplied by 1, giving you back the even number. And there you have it. All axioms are satisfied except for number 6.